Okay, we're going to take a look at some redox examples here, and the first thing I want to do is I want to just draw your attention to the standard reduction potentials. This is a document that is included in your content, and certainly something that you would want to print out and have handy. It's 2 pages, you can see. Contains most of the reduction potential half reactions that you're going to need for this unit. You'll notice that I've also added a couple of annotations to the side here. So if we look at the left side here, so if we look at all of these reactants, then they are ranked in order of decreasing oxidization. So your strongest oxidizing agent is going to be fluorine, and then if you go to the end, this is going to be your weakest oxidizing agent, so lithium plus. On the right side, so if we're looking at the reactant, or the product side, sorry, then our reducing agents are increasing as we go down. So the strongest reducing agent is going to be lithium metal. The weakest reducing agent is going to be the fluoride ion. Okay? The other way to think about this is reduction is going to increase, so strength of reduction is going to increase as we get to the top. Strength of oxidation is going to increase as we get to the bottom. Also, reduction is always associated with the cathode. So reduction occurs at the cathode, and the easiest way to remember that is red cat. So red cat. Okay, that's how I always remember that. Okay, so now that we have this, we're just going to kind of keep this off to the side, and we'll look at the first example from the homework, which is what is the potential for the reaction chlorine plus 2 iodide yields 2 chloride plus iodine. So let's just write that out. Alright, so that's our reaction. The first thing we're going to do, and since it's going in this direction, we're just going to split it into its half reactions. So we got chlorine, and on this side we've got 2 chloride ions. The other reaction is 2 iodide and goes to iodine. Now, here you have a charge of 2 negatives. So the only way that that's going to happen is if we add 2 electrons. And likewise, here we have 2 negative on this side, so we have to have 2 negative on that side. So we've got these 2 half reactions. Okay? And since the reaction is going in this direction, we're going to look up the first one. So we go to our chart and we're going to find chlorine, and it is right here. So you can see chlorine plus 2 electrons gives you chloride, and that has a voltage of 1.36 volts. So let's just put that over here, 1.36 volts. Okay? And what's happening here is we're gaining electrons, so this is reduction. Here we're losing electrons, so this is oxidation. Remember, Leo the lion goes grr. So, okay, we're going to look at some examples of redox reactions, and before we get started, I want to make sure that you are aware of the standard reduction potentials table that is in your content. I would suggest you print this off and have it for handy reference so that you're not constantly looking it up. A couple of things that I've added to this, you can see that I've labeled the oxidizing agents, the strength of the oxidizing agents. They are on the left side, so fluorine here, fluorine gas is going to be the strongest oxidizing agent. And if we go all the way down to the second page, then the lithium ion is going to be the weakest oxidizing agent. On the other end of things, so the right side, so all the products, represent the reducing agents. So the strongest reducing agent is going to be lithium metal, and the weakest reducing agent is going to be the fluoride ion. Okay? Also important to remember that reduction occurs at the cathode. So reduction increases as we go up the values, so the higher the value, the better the reduction, the better the oxidizing agent that is. And as the values get smaller, the worse the oxidizing agent and the better the reducing agent. So oxidation increases as we go down. Cathode, reduction occurs at the cathode. You can always remember that as red cat. Okay. All right, so we've got that. Let's take a look at some of the examples from the worksheet. This is Activity 2, Redox Reactions. We're going to do the first one here. So what is the potential for the reaction chlorine plus 2 iodide yields 2 chloride plus iodine? So we're going to start by writing out that reaction. So Cl2 plus 2I negative yields 2Cl negative plus iodine. Okay? And we're going to split that up into the two half cells, starting with chlorine going to 2 chloride and then 2 iodide ions producing iodine. We can see that we have a charge of 2 negative on the right side, so we need to add 2 electrons to balance the charges. If we're gaining electrons, we know that that is reduction. 2 iodide ions, so we've got a negative 2 charge on the left side, so we have to add 2 electrons here, and that means we're losing electrons, so that is obviously going to be oxidation. Leo the lion says grr, gain of electrons is reduction, loss of electrons is oxidation. Now if we go back to our table and we look up the reduction potentials for these two half cells, we can find chlorine is right here, and it has a reduction of, a voltage of 1.36, so 1.36 volts. And then if we look up this one, it is right here, but it's written backwards. So instead of 0.54, we have to flip it. This becomes a negative 0.54 volts. When we add these two reactions together, we get our original reaction. And the electrons cancel, so we get Cl2 plus 2I negative gives us 2Cl negative plus I2. And if we add the potentials, 1.36 plus negative 0.54, that's going to give us 0.82 volts. And if we look up on the sheet, that means our answer is B, 0.82 volts. Now the other way that you can do this, and what's shown in the notes, is that the E naught for the total reaction is just the E naught for the reduction minus the E naught for the oxidation. Okay, that's the formula that's given in the notes. If you're using this then, in this case, you wouldn't reverse this. You would just go 1.36 volts minus 0.54, because that's how it shows up directly on the chart of half cell reductions, but it still gives you 0.82 volts. So you still get the same answer. But I think I like this way because it's adding the two half reactions, and therefore you're also adding the two potentials to get the overall reaction potential. Also, if it's positive, you know that the reaction is going to proceed as it's written. If this is negative, that means the reaction is not going to be spontaneous and it's not going to go. So that's the first